Hydraulic lift system. Could the same hydraulic system used to lift hundreds of tons in the industry be applied to retrieve the 46,000-ton Titanic wreck? Surprisingly, some scientists believe so. In basic principle, an array of large hydraulic jacks would be positioned beneath the hull of the Titanic and anchored to the seabed below. Thick steel plates would help distribute the lifting forces across the underside of the wreck. High-pressure hydraulic fluid, pumped down from surface vessels through reinforced hoses, would then power the synchronized extension of the jack's piston arms. In this way, the Titanic would be slowly lifted, as if on an underwater platform. But herein lies the first monumental challenge: developing hydraulic jacks capable of hoisting such mind-boggling weight under the pressures found at that extreme depth. The jacks must output lifting forces strong enough to physically overcome the inertial and frictional resistance holding down an 850-foot-long ocean liner after a century on the seafloor. That requires hydraulic cylinders engineered with the highest pressure capacities and load ratings in the world. Positioning the jacks is also critical. Too few connection points could crush sections of the deteriorating hull under concentrated loads. But ringing the entire wreckage would require a sprawling hydraulic network and invite unbalanced lifting forces. Comprehensive structural analyses and simulations would be needed to find the optimal jack placements to avoid failures. Keeping dozens of colossal hydraulic jacks synchronized in real-time miles down on the pitch-black seafloor could border on impossible. This would be an extremely complex lift evolution with zero room for error. It demands maintaining perfect harmony between the jacks to avoid structural distortions or breakages as the Titanic is nudged upward. The coordination of pressures, flow rates, and speeds is akin to a symphonic ballet, except with machines capable of crushing steel. Therefore, while lifting the Titanic through a gently rising platform of hydraulic jacks has engineering merit on paper, the technical barriers surrounding power, precision, control, and calibration at real ocean depths confine this method to the realm of theory. The risks surrounding implementing so many fine-tuned heavy-lift hydraulic systems miles deep in the hostile Atlantic may conspire to keep the legendary liner permanently grounded on the seabed. Number 2. Mass displacement. What if we could raise the Titanic not by lifting the wreck,